This is a carburetor. Specifically, this is the one off of that little rig that I was working on that I got for free, the little three-wheeler. I had a little mental lapse, just thinking visually for a minute. So anyway, the way that the carburetors work is you have a bowl, and the bowl goes in the bottom, and you have a fuel line going in. This is a fuel line that goes to the bowl, and you can see kind of the casting there, and then it goes to your needle and seat. It goes down and comes through this little spout, and the float opens and closes that little valve, and that little valve is your needle and seat. So if I take out this pin and set it aside, it's just like in the back of your toilet you got that little thing, only this is gravity fed instead of water pressure fed. But you've got this little, this is called the needle. It looks more like some kind of Empire State Building or something to me, but anyway, that's it. And it's got a little spring-loaded clip that goes on the float. And you can see, you can just take it out and look at it there. And these floats float in the gasoline in the bowl. And when it gets full, the float goes up and it pushes that needle into the seat. And it closes it. It's got a little rubber tip on it, and it just plungers it shut. So that's how that works. So your bowl will have a certain level of fuel in it at all times. Now if that little needle and seat get full of crud, as this one was, when the gas comes in, it'll be stuck shut, because say it was left full of gas, it'll be in the closed position. It doesn't matter how much gas you have, it won't go into the bowl. Bowl's empty. Now that matters because the jets are what give you gas to the rest of the vehicle. And if you look at the definition of a carburetor, it says an ingenious method to crudely measure air-fuel mixture, or meter air-fuel mixture. There's a difference between measuring and metering. This is a meter. And so this is the choke. In this position, the choke is off. And when you think of choke, I want you to think of strangulation, just cutting off, Bart Simpson being strangled by Homer, basically. You're closing the airway. So when you choke something, you restrict the airflow, and it makes it richer. So when we put this choke on, now see there's half choke, no choke, completely choked. So what we're doing is we're choking the carburetor off completely. Now when this is all blocked off, where's the air going to travel? It'll get through the crack a little bit right there. This is a design flaw, but it'll go through here and here. So you have these little air jets. So when you take a carburetor and you want to clean it out, you want to be sure to clean all these things. What I like to do is you can do a chem dip, but I like doing the B12 chem tool. So I stick my straw in there, make sure that you're wearing safety glasses, and just hit that like that. You see how it comes out through different jets. It's squirting out the top of it here, and then here it's squirting out the bottom of it. So if I have this thing choked, I know that that's good. Now the jets, when you have it running properly, I'll shake that off. The jets in the circuit of the carburetor work like this. And it doesn't matter if it's like a high-performance motocross bike. Well, they're all fuel injected now. They're going that direction finally. But this is your main jet, and this is full of gas, the carburetor bowl. The way that it works is the main jet works kind of based on Venturi principle. When you blow across the top of something, it pulls the fluid up and out of it. Like if I had a glass of water or a bottle, and then I used a compressor and blew across the top, the air would go in, and some of it would catch, and it would swirl and pull the water out. If I sprayed across the top, it would blow it out. I'll do a demonstration of that here, show you what I mean. So here's my container filled with water. You can see the little line on it, and I've got a straw in there. Now the way this works, a lot of paint guns, carburetors, everything are based on the Venturi principle, V-E-N-T-U-R-A, or I, sorry. But you just blow across. Now imagine this blowing is like the air going through the barrel of the carburetor, and as you blow across the top of the straw, you basically crudely meter water out of the straw. So it does a little thing like that. Now the different size straws are like your different size jets. By the way, if your house is really dry, it's a great way to humidify it. Now, of course, when you have lower pressure air moving over it, it's not quite as dramatic, but kind of fun. That's the Venturi principle. It just sucks the water through the straw because you create really low pressure. It creates a vacuum right here because the air is rushing across. Air sticks to itself just like water does, and as you go across the top, it's being sticky to all the air and it drags it out with it. Well, as you drag the air out and there's nothing there, you get a vacuum. The vacuum pulls the water into it, and then the water starts to pull out. And the water has surface tension, and it pulls it out too. So it's just basically like it's all connected as a chain, the air and the water and everything. And as you pull it out, it pulls out like string or chain or whatever else. And that's the Venturi principle. Okay, so now that you understand that principle, this jet is going to have itself immersed in gasoline pretty much to the bottom. So this is your wide open throttle jet, your big main jet, and it comes up to right there, and you have a little needle that goes up and down into there, and it basically gets pulled up the needle and into the vehicle. So when you got the throttle halfway to wide open, or at least a quarter open, you're on your main jet. So if you're going to clean a carburetor, if it runs good, it starts, but as soon as you go to give it a bunch of gas, it dies. That's because this is clogged off. That's the circuit that's used for that. Now this next little jet, the further one down in here, this is your low jet. This is at low speeds. This is when you first start to crack the throttle that you get onto that. And then this adjustment here, this is your air needle, and it's not even in the gas. It's on the outside of the carburetor bowl. Now when I go to do this and I cleaned it out, I've already done it on this one, but watch, I'm straight up and down, right? So I count as I bottom out the air needle. I go 0.5, 1, 1.5, 2, and that's it. That's all it'll go. So I'm bottomed out. And there'll be a little screw inside of there. Sometimes the screw comes out, sometimes it doesn't. But if you're going to clean the carburetor, you see it's a little needle, just like the needle that goes down through the top, with the throttle. If I were to use my dental tool and pick at this, I bet I could get that spring to come out, but for sake of time and giggles, I won't. And see this teeny little hole here? That teeny little hole is part of that little jet. You can see daylight through that. So you'd want to clean that out. You just spray through there. If any of these little holes get blocked, then you're not going to be able to start, or whatever circuit will basically be shut down. So you can tell, even just by driving the thing, which jet's bad. This one's on the low end. So we'll tighten that all the way in. We'll bottom it out. Okay, so right there. So we go 0.5, 1, 1.5, 2. And we're right back. We preserve the original setting. So that's just a little tutorial on the carburetor. Now I'm going to have to go to the bike to show the next part. The barrel that goes into here that blocks it is basically the throttle butterfly, or equivalent thereof. It goes down into here, and you can see there's a screw on the side. This screw meets with a sloped surface on the throttle butterfly, and as I screw it in, as that goes in, that'll push up on the throttle butterfly because it'll be cut kind of at a slope at a 45-degree angle. So the more I tighten this in, the higher it holds that open. The more it holds it open, it's like twisting the throttle. When you twist the throttle, it pulls it up and down. I'll show you here in a minute. One more quick little thing to discuss is when the throttle's in the closed position or just barely starting to open and this needle's clear down in that main jet, how far that needle sticks down in there and the shape of the needle makes a difference for when you first get off and first start to pull this up. And you can change that position. There's a little E-clip in there, and there's usually about 5 to 7 different clip positions to change the length on how far down in there that sticks. And that's another way to change the performance of your carburetor or tune your carburetor, for just when you're just getting off idle, when you just barely first crack it. So, alright, so here's the barrel of the carburetor, basically a throttle butterfly, and you see when I push on the throttle it pulls it up. So once this is put into the carburetor, let me wipe it off because it's been sitting on the dirty part of that. But you look at it and you can see that it's cut at a slope, and then you can see a little silver mark right there where that screw was hitting. So it was sitting almost all the way down in there. So remember the screw that sets our idle right there. You got to twist it, get it to fall in there, and screw the top back on it. I have to take this right back off to there we go. So now when I hit the throttle, it opens it up. That's wide open throttle, there's half throttle, there's closed throttle. So when the throttle's closed, just a little bit of air gets by. And you see there's kind of an opening at the bottom of it there. You can see the needle. And that needle, as I said, goes down into the main jet. So if that's throttle closed, fully choked, and it would just be going through those two little air holes. So on a starting circuit, one of these is a starting circuit, and then the other's just an air bypass, for when it's fully choked. That's how a carburetor works. And on this one, you've got one more screw down here, and that is a drain, so you can drain the fuel out of your carburetor bowl. See, it's like you run it totally out of gas. So if it sits for 10 years like this one does, it won't get full of deposits and debris. So this carburetor, it's ready to rock. It's ready to go. Now this is the drain tube for the drain. So if I undo the screw, all of the fuel in the carburetor will go down that. And then this is the overflow. Now if my needle and seat get stuck in the open position and I have free flow of gas going from the gas tank down into here, filling that up, it'll fill up to here, and then it'll overflow out that side tube out the top of the bowl. And the reason why you have that is so that you don't fill the engine full of gas and hydrolock it, or cause it to just be so flooded it won't start. So anyway, I hope you like my video about carburetors. I get a lot of questions on carburetors, and this will help get you where you need to be, especially with motorcycles, lawnmowers, a lot of trim, a lot of small engine stuff. But the same principles apply to a car. They're just bigger, and there's duplication. Like this is a single barrel carburetor. It just has the one opening, and you'll have 2-barrel carburetors, 4-barrel carburetors, and so on. And oftentimes with motorcycles, instead of a 4-barrel carburetor, they'll have 4 carburetors that are all hooked together side by side. So if you like this video, click subscribe. If you want to see more like it, that's the way to see them. If you have any questions, put them in the comments below. Or if you just want to say thanks, or be like, hey, I learned this thing and thanks, whatever. And be sure to click like it if you liked it. Thanks.